So now we're going to discuss types of relations. This is a primitive type of relation that's called reflexive. We say the relation on a set is reflexive if for every member of the set you have a loop. Okay? अगर हर member के लिए आपके पास loop है तो you call that set reflexive relation. Okay? So for example, all of these relations are reflexive. These are diagrams of reflexive relations. Okay, this is a reflexive relation on 3 elements. This reflexive relation on 2 elements. This one is on 2 elements. This is on 1 element. Okay. Questions? No. Okay. I'm going to ask questions. Which of the following relations are reflexive?
First.
Is R1 reflexive? R2? R2 is not reflexive. Why? Why? 4 is not there. Yes. R3? Okay. Yeah. R4? 1 is missing from R4. All right. Which of the following relations are reflexive? Okay, so 1 and 3 are reflexive, 2 and 4 are not. Oh boy, no, not again. Okay, I'm not going back to slides again. We say the relation is irreflexive if for every pair the loop is missing. Okay, so all of these sets are irreflexive or anti-reflexive because none of the loops are there. 1 is not there, 2 is not there, 3 is not there, 4 is not there. Okay. How about this one? Is this a reflexive relation? Is it? Yes? No? Yes? Why? So reflexive की definition याद है? Can you repeat? So reflexive की definition. What's a reflexive relation? You know it. Just say it out loud. बोलो. Okay. No. So a set is reflexive if every loop is there. Okay. That's the definition of reflexive set. Okay. Since this loop is missing, this is not a reflexive relation. Okay. And this is again not irreflexive and not anti-reflexive because some of the loops are there. Okay. For anti-reflexive, you want all of the loops to be missing. Does it make sense, Rian? Yes? Okay, cool. So for reflexive, you want all of the loops there. And for anti-reflexive, you want none of the loops there. Okay? Which means that ये वाला relation ना तो reflexive है, ना anti-reflexive है. Okay? Because some of the loops are there and some of the loops are missing. Okay. Symmetric is, I believe, what you were saying. Symmetric says that if you have a pair 1, 2, you must have a pair 2, 1. Okay? For the relation to be symmetric. Okay? Symmetric relation यहाँ पे है. I'll fix it before I upload the slides. Okay? Okay. How about these relations? Do you see any reflexive? Sorry, symmetric. Okay. Are any of these symmetric? Is R1 symmetric?
No.
R1 is not symmetric. Why not? Why? Yes, it's reflexive, but why is it not symmetric?
Because 1, 2 or 2, 1 after something.
Sure. No. Okay. So again, the condition for let me go back to the definition. Definition says that if one of the pairs is there, okay, if xy is there, you must have yx. Okay. What? Sorry. दो बार तो कभी नहीं आ सकता, okay? क्योंकि it's a set, okay? The relation is a set. You cannot have one twice, okay? So this is what it's saying. You should be able to read this formula now and try to understand कि इसका क्या मतलब है, okay? So this is what it's saying, that if x, this is a conditional statement, okay? It's saying that if xy is there, yx must be there, okay? For every xy in A, okay? So given this definition, is this thing reflexive? People who say no. Okay, it's reflexive, yeah. But is it symmetric?
No.
It's not? People who say no. Oh, okay, we have a lot of people here. Let me start with who wants to start? I'm looking for justifications. You want to start? Mubin? Okay, Mubin, go ahead.
आपके पास है x y होगा तो y x होगा
होना चाहिए, yes.
तो इसमें मतलब 1 1 है और मतलब सारे बराबर हैं
Okay.
मतलब x x नहीं आपने x और y को वो तो सारी रूल्स है ना
प्रोफेसर फिर हर रिफ्लेक्सिव सेट सिमेट्रिक भी होगा.
You tell me. I have no idea what this statement says now. You guys are the logicians now. You should be able to tell me what this means.
सिमेट्रिक और रिफ्लेक्सिव सेट जब रिफ्लेक्सिव है तो सिमेट्रिक भी होगा.
आपके सारे इफेक्ट होंगे.
Yes. Anyone else? Ibrahim?
If we have x y and y x and both are same it will be independent.
So the thing is, देखो यहाँ पे कहीं पे नहीं लिखा हुआ कि x and y must be different, है ना? कहीं पे भी नहीं लिखा हुआ, okay? So since यहाँ पे कौन कौन से पेयर्स हैं? यहाँ पे एक पेयर है 1 1, okay? जहाँ पे x 1 है और y 1 है, okay? अब मैंने ये चेक करना है कि is there a pair 1 1 there? Is there? There is definitely, right? Which means it does not violate the condition of symmetry, okay? और इसके बाद मेरे पास पेयर है 4 4, okay? But is 4 4 there? Okay? So हर पेयर की symmetry वहाँ पे मौजूद है. There is no xy for which yx is not in my set. Okay? That's why this thing is symmetric. There is total symmetry in this set. Okay? Are we good? All right, let's move on to the next. Are there any complaints? Confusions? All right. How about this one? Is this symmetric? No. This is not symmetric. Why? Yeah, 1 4 is there and 4 1 is not there. Okay, cool. How about this one? This is symmetric. How about this one? 1 3 2 2 3 1 2 4. Yeah, 2 4 is there and 4 2 is not there. Let me give you an example of a relation and ask you the question. Here's my relation R. Is this symmetric? Is it? It's not? Hafsa?
There's no x or y.
There is no x in my soul? It's symmetric. It's totally symmetric. For every pair xy that's in this set, I have a yx in there. Since there is no xy there, I don't need to find a yx. There is no pair in here that violates the condition of symmetry. Okay? So you need to think about the things that are destroying the symmetry in your relation. Okay? There is nothing in this set that's destroying the symmetry. There is no pair xy in here that for which yx is not available. Okay? Since there is no xy, I don't need to find yx there. Okay? Good? Okay, let's move on. So this is symmetric, this is not, this is symmetric, and this is not. Okay. Anti-symmetric is symmetric is a relation where there is absolutely no symmetry. Okay. What that means is that if there is, okay, yeah, let's read this. Okay, I want you guys to be able to read this. What does it say? So what does it say?
X and y, what should belong to the set?
जोर से बोलें.
X and y, what should belong to the set?
Yeah. Okay. Cool. Yeah. I can accept that definition. Okay. So what she's saying is that if you have a symmetry anywhere in your relation, if you have an xy and you have a yx, then they should both be same. You cannot have symmetry except for the loops. Loops are allowed. This thing is saying that loops are allowed, but loops are the only thing where symmetry is allowed. Nowhere else should symmetry be allowed. Okay? So it's saying that if you have a symmetry somewhere, if you have an xy and you have a yx, this must be a loop. It cannot be anything else. Okay? Okay, cool, right? Let's see some examples. Where are the examples of symmetry? Am I at the end of my rope? Okay, just give me a couple of minutes, 2 minutes, okay? Sorry. Yeah, okay, we don't have any example, so I'm going to come back to this thing, okay? Is this set anti-symmetric? Yes? People who say yes, and people are so scared now. It's all right to be wrong, okay? I'm about at least 10 times wrong in this class, every time, okay? It's all right to be wrong. Is this set anti-symmetric? Okay, either you are wrong or almost a lot, or everyone else is wrong. It turns out that it is anti-symmetric, right? There is so what the definition says is that wherever you find symmetry, you should be at the loop. Okay, I can't find symmetry at all, which means that I'm fine. I don't need to be at the loop. Okay, okay. So this set is this is symmetric and this is also anti-symmetric simultaneously. Okay, you can have a set that has that property. You can have a set that's एक moment पहले हमने देखा, you can have a set that's reflexive and anti-reflexive at the same time, and you can have a set that's symmetric and anti-symmetric at the same time. Okay, we'll see transitivity next week. Okay, but I think that's enough for today. Okay, see you next week. Thanks.